Okay, class. So we're going to continue with part 2 on circles. But before we move a little forward, there's about 5 new rules that we need to learn. 5 new rules could be called postulates or theorems, which we've discussed before. I like to just call them rules. So let's take a look at the first rule. The first rule states that the measure of an arc formed by 2 adjacent arcs, that means by 2 arcs that are next to each other, is the sum of the measures of the 2 arcs. Remember that sum means addition. So what does that mean? That means then that the measure of arc ABC in blue, we take a look here, here's arc A to B to C, and we know that's a major arc because it's more than half the circle. I know that the arc ABC came from adding arc AB plus arc BC. If you look here in pink, here's arc AB. If you look in green, here's arc BC. And when I add arc AB and BC together, I get arc ABC, a major arc. Let's take a look at some examples. Let's take a look at this circle here. Let's find the measure of arc GE. Remember, guys, when you're looking for the measure of an arc, you're always looking for the shortest distance between the two endpoints. So let's take a look here. GE, arc GE goes from here to here. Well, I know that G to H is 40, and I know that H to E is 80. So then, by going by this rule up here, that means that I should add these arcs together to get arc GE. Well, if you notice, my central angle here is 40 degrees, which means that arc GH is also going to be 40 degrees. If you notice here, this central angle is 80 degrees, which means that arc HE is also going to be 80 degrees. So if I add 40 plus 80 from G to E, I'll know exactly how big arc GE is. Let's add 40 plus 80. And that gives us 120 degrees. So arc GE is 120 degrees. Let's take a look at arc GEF. We're going to go from G to E to F. Well, here's G to E to F. Okay? Well, we know that from G to E is 120, because we've answered that here. But what about E to F? Well, notice that this central angle is also 110 degrees. Notice that this central angle is 110 degrees. So then the arc that it makes is also going to be 110 degrees. So when I measure arc GEF, well, I'm going from G to E to F. That's going to be 40 plus 80, which I know is 120, plus 110. So let's add all those together. 40 plus 80 is the 120, plus the other 110 degrees that I have here is equal to 230 degrees. So arc GEF is 230 degrees. And I know that arc GEF is a major arc because it's more than 180 degrees. It's 230 degrees. So arc GEF is 230 degrees. What about arc GF? What about this arc right here, G to F? Well, we know that a circle has how many degrees? 360 degrees. We know that from G to F, it's 230 degrees. So all we're missing is this little bit right here. So how are we going to find that little bit right there? If all of this is 230 and a circle has 360, how are we going to find this missing part right here? Well, if you said subtraction, you guessed correctly. So we're going to subtract 360 from all of these arcs right here, which come out to be 230 degrees. So 360 minus 230, 360 minus 230 is going to give us 130 degrees. So then we know that arc GF is 130 degrees. And judging by its measure, we can tell that it is a minor arc because it is less than 180 degrees. So arc GE is a minor arc. arc GEF is a major arc, and arc GF is also a minor arc. Let's move on to another rule. Let's move on to our second rule. Second rule says that in the same circle, two minor arcs are congruent if and only if their corresponding chords are congruent. We're going to focus just on the same circle here because we have one circle. And notice how we have these two chords here. Remember that a chord is a segment which touches 2 points of the circumference and it doesn't go through the center. Here I have chord AB, and here I have chord BC. Those are chords. I know that they are congruent because there is a congruency dash in between both of them. There's a congruency dash. And what this rule is saying that if I have two chords in the same circle, two minor arcs, so if two minor arcs are congruent if and only if their corresponding chords are congruent. That means that two small arcs that are less than 80 are going to be the same if the chords that make them are the same. If the chords that make them are the same. So let's take a look here. Let's zoom in on here. Let's take a look at this circle here. Notice that this chord, AB, creates an arc. I'm going to highlight that in blue. And notice arc BC also makes an arc. I'm going to highlight that in green. What this rule is saying is since arc AB is made by this chord and arc BC is made by this chord and both of these chords are congruent, then if they're minor arcs, then both of these arcs will also be congruent. That is all that rule is saying. Let's move on to another rule. Let's move on to our third rule. The third rule states that in a diameter of a circle, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So let's take a look here. If a diameter of a circle, here's a diameter right here, here's a diameter, is perpendicular to a chord, well, here, let me highlight my diameter in green. Let me highlight my chord in blue. I know that they're perpendicular because I see a right angle forming here. I'm going to put that in pink. And this rule is saying that if a diameter in green is perpendicular to a chord in blue, then that diameter is bisecting the chord and its arc. That means that if this diameter is perpendicular to this chord, then it's cutting this blue chord into two congruent parts, meaning that DE is going to be congruent to EF. But not only is it cutting just the chord into two parts, it's also cutting the arc into two parts. Notice here that this blue chord, DF, makes an arc, a minor arc, DF. Well, since this green line is perpendicular to this chord, and this chord is being bisected into two equal parts, well then this arc that's made by this chord is also being bisected into two equal parts, meaning that this part of the arc, DG, is going to be congruent to this part of the arc, GF. That is what our third rule is saying. Let's look at our fourth rule. Let's look at our fourth rule. The fourth rule states that if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Let's take a look here. If you remember, we said that a diameter is a special kind of chord. we said that a diameter is a special kind of chord. A diameter is a chord which goes through the center of a circle. So here I have two chords, JK and ML. And all it's saying is here, let me put my diameter in green, and let me put my chord in blue. And all this rule is saying, by the way, notice that there is no center of a circle here. Notice that there's no indication that green is a diameter. They're not giving us any clues. Notice they didn't put 180 anywhere or anything like that. So, how do I know that this is a diameter? How do I know that this green, oh, because it looks like it's going through the middle? That's not enough to prove it. Here's what this rule is saying. The rule is saying that if I have one chord in green and I have another chord in blue, and this chord in green is cutting this blue one into two congruent parts, then the first one has to be a diameter. The first one has to be a diameter because the diameter is the only kind of chord that can bisect another chord and be perpendicular. So if this green chord is bisecting this blue one and it's making 90 degrees with it and it's perpendicular with it, then the green one can be identified. You know for certain that it is a diameter. You know that it's a diameter. That is our fourth rule. Let's take a look at our fifth and final rule. And then let's take a look at a question that we're very likely to see in the EOC examination. The final rule says that in the same circle, or in congruent circles, by the way, they always say congruent circles, meaning in identical circles. But in the same circle, two chords are congruent if and only if. That means that this if and only if they are equidistant from the center. So two chords are going to be congruent only if they are the same distance from the center. So let's take a look here at this circle. Okay? Here, I'll know for a fact that chord AB is going to be congruent to chord CD if the distance from E to F is the same as the distance from E to G. If you notice, my chord here is about this distance, whatever this distance is. Let's say this is 3. Let's say it's 3 inches from here to here. Okay, it's not a complete radius. This is not going all the way out. It's just from here to here. And let's say that if this is 3, let's say that if this is also 3. Let's say that E to G is 3. Well, if the distance from E to F is 3, and the distance from E to G is 3, you notice here that the chord CD is 3 from the center, and chord AB is 3 from the center. If both these chords are the same distance from the center, then they have to be congruent. They have to be congruent. That is what that rule is saying. So let's take a look here. Let's take a look at an EOC question very briefly. Let's say they tell us that in a circle, AB is equal to 8, DE is equal to 8, and CD is equal to 5. And they ask us to find CF. Let's take a look here at this picture. So if you look here, they tell us that chord AB is 8. So I know that this is 8 units. I also know that DE is also 8 units. I'm going to put them both in green. Okay? They're both in green. Okay? If both of these are congruent, then I know that they are the same distance from the center of the circle. They have to be the same center from the circle. They also tell me that CD is equal to 5. If you notice here, from C to D, this is also equal to 5. And they want us to find C to F. They want us to find C to F. Okay, well, let's take a look here. I know for a fact that from A to B, this is 8. I also know for a fact that from D to E, this is also 8 units. I know that C to D is 5, and I know that these two chords are congruent. So if they're congruent, they have to be the same distance from the center, meaning that from C to G is going to be the same as from C to F. Now, how can I find C to F? How can I find C to F? Well, would you agree with me that if I said that if I knew CG, then I know CF? So the question becomes, how do I find CG? Well, if you notice here, I know that DE is 8. And I also know that chord DE is perpendicular with CG. If DE is perpendicular with CG, that means that CG has to be bisecting this chord here. So cutting it into two equal portions. So if this whole chord is 8 and it's perpendicular, then I know it's being bisected. So then that means that D to G is 4 and G to E is also 4. And I hope you notice here that what you have is a right triangle, where this is the hypotenuse and this is the leg. And if this is 4 and this is 5, we can find CG using the Pythagorean theorem. A squared plus B squared is equal to C squared. So where 5 is my hypotenuse. So then I would say that, let's say that this is my A of the leg, this is my B, and this is my C. All I would have to do is A squared plus B squared is equal to C squared. This would be 4 squared is equal to 5 squared. A squared plus 16 is equal to 25. I subtract 16 from both sides, and A squared is going to be equal to 9. But I don't want A squared. What do I want, guys? I want just A. So I'm going to take the square root of A squared and the square root of 9, and A is equal to 3. So then I know that this part of the triangle is going to be 3. And if CG is 3, well, then we know that CF is also 3.